See, full power.
Okay, I think let's get started. People will join. So yesterday we were talking about polynomial multiplication. So we had two polynomials of degree n minus 1. So that is n terms each. And we wanted to multiply. And then we analyzed if we use a very naive method for doing that, we will take order. What was the complexity? By using a simple method?
N square.
Order n square.
N square.
And then we said, okay, can we use divide and conquer? And then we divided polynomial into two parts. So each part has roughly n by 2 terms. So we call that low and high. And then we said, okay, we can write it in this form. And then we said from here, I can get the final formulation as this. Yes, that's where we are. So, yeah. So that's where we were. And we also found out the corresponding recurrence relation, that is Tn is 4 times Tn by 2 because there are 4 subproblems. 1, 2, 3, and 4, each of size n by 2. Plus, we do some order n work. And we also saw a Master's theorem that can directly tell me that this is order n square. And then we said, okay, this is like, we tried to divide, but we could not conquer. We could not get a better solution than what we had originally. So now we have to think what else we can do. So yesterday we were just discussing how we can improve this efficiency. So right now we have 4 subproblems, each of size n by 2, multiplying two polynomials of n by 2 terms. We have 4 subproblems. What can I do to improve this? So one thing that came to mind is that, okay, instead of 4 subproblems, if I can reduce that to 3 subproblems, then I'll get Tn as 3Tn by 2 plus On, and that will surely be less than order n square. But how can we do that with less than 4 subproblems? What can we do? We have to compute all 4 terms. We have to compute this, and this.
The first 3 terms to be calculated, and the fourth term would be found by multiplying the last 2 terms, dividing by the first term.
Okay, so you are saying these are polynomials. What are you saying about dividing? They are polynomials, they are not scalars. And if you multiply, if you compute 3 terms and multiply, you are doing a 4th thing, right? So already 4th subproblem is there. If you multiply them.
Sir, we can write middle term as AHI plus ALO into BHI plus BLO minus
Okay.
AHI BHI minus ALO BLO.
So here's something. He's saying this term I can write as AHI plus ALO times BHI plus BLO minus AHI BHI minus ALO BLO. Can everyone verify this is fine?
Yes, sir.
Okay. Fine, I can do that. But how does that help? How does that help?
Sir,
So
we have AHI, BHI.
instead of two multiplications, you are doing 3 multiplications. So how will it help?
Sir, we are already calculating AHI, BHI, and
Right.
Sir, AHI, BHI, and ALO, BLO are.
So let's see how many multiplications you are finally doing. So this is 1. You add and multiply, only one multiplication. This is 2. This is 3. And then you have AHI, BHI, that is nothing but 2. This is 2. ALO, BLO is nothing but 3. So you have to do only 3 multiplications, right? And that's all. Just by doing an extra addition, yes.
Sir, but AHI plus ALO times BHI plus BLO is AX plus BX, which is
No.
what
Why? Who said that you have to open it and then do it? You can first do addition, right, in both the parts, and then do a single multiplication. It's a single multiplication.
No, sir, I'm asking that this is the exact term in the LHS, right? Because AHI plus ALO is the entire A and
No. That is XT times AHI.
Oh, okay, sir. Okay, sir. Yes, sir.
That's not the same.
and sir, but here the size of the problem is n, like AHI plus BHI. AHI
Both
plus
are n by
ALO.
2. Both are n by 2 degree. Both are n by 2. That's how we are breaking them. Each of this is n by 2 terms. The coefficients are from 0 to n by 2 minus 1. If you just add the coefficient, it doesn't matter. They will still be between 0 to n by 2 minus 1. Right? Is there some difficulty here?
No, sir.
Okay. So please do not think them as a scalar. They are all polynomials with some coefficients, and they are up to n by 2 terms. Each one has n by 2 terms. If you add, doesn't matter. They will still have n by 2 terms. Right? So you are multiplying two polynomials of n by 2 terms. So that is 1. Same in 2, same in 3. Okay. So if you do that, then you get Tn as 3Tn by 2 plus On, and immediately now you can get n to the power log 3 to the base 2. Okay, and this is anyway less than this, so this is your complexity, and that comes out to be order n 1.58. Right? That is less than order n square. So you see, by using divide and conquer plus an additional trick, you could take your complexity from order n square to order n to the power 1.58. Okay? And this is called Karatz-Subaj polynomial multiplication. Okay, any difficulty with this?
Sir, suppose degree was different. Even then, we can apply this thing.
Some coefficient will be 0.
So we will take maximum of the both.
Yeah, maximum of the 2 degrees.
Okay, sir.
Any other question? Now the same idea you can use for other things. For example, try on your own large number multiplication. So suppose you have two numbers. One is like 3, 4, 5, 8, 9, 2, 1, 0, whatever. So this has n digits. Another number that also has n digits. If it doesn't have n, you can take maximum of both. So they have n digits and you want to multiply them. Okay. So what can you do? Can you improve the complexity by using divide and conquer? And hint is that this is just a straightforward extension of polynomial multiplication. Some of you might already be able to see what we have to do. Yes, can anyone tell just in a line what we have to do?
Each
We will
digit
divide.
is a quotient of x
Yeah.
power.
Think of these as the coefficients. Think of these as the coefficients. And this is coefficient for the largest degree, 10 to the power n minus 1, right? 3 times 10 to the n minus 1 plus 4 times 10 to the n minus 2 up to this number. And this is just direct mapping between this problem and polynomial multiplication. So large number multiplication you can do in a very, very similar manner like we did here. Another very interesting problem that you can do is called matrix multiplication. This is not so straightforward, so I'll come back to that after I give you another example, but I'm just putting this down. You can use similar ideas for matrix multiplication, just that the trick is not so obvious. The trick there is not so obvious. So, yeah. So I'll come back to this matrix multiplication. But what is the problem? You have two matrices, A and B. Both are n cross n. And you want to multiply them. You want to multiply them. So what is the complexity of matrix multiplication?
N cube.
N cube.
And
Good. So its complexity is n cube. Question is then n cube. So how would you apply divide and conquer? What can you do with the matrices?
So you can divide in upper triangular and lower triangular.
No. Do something else.
So divide
So
into
can we
4
divide it
parts.
into 4 parts?
2 cross 2. Okay, and think of it as 4 matrices. R, S, T, U. Sorry, let's call it A, B, C, D. A, B, C, D, and this is E, F, G, H. So they are all n by 2 cross n by 2 matrices. So A to H are all n by 2 cross n by 2 matrices. Now, using this, you can write what is the C matrix. R, S, T, U. What will be R? I'll just ask what is R.
AE plus BG.
A, E plus BG, right? R is AE plus BG. You can just write like your normal multiplication, but they're actually matrix multiplication. So similarly, you can write all the 4 terms. Okay, S, T, U. They will be like similarly, like S will be B, no, AF plus BH, right? AF plus BH. And similarly, you can write other terms. Now, there will be 2 terms in there. If you do that,
Sir, is this valid only for n equal to even? Because if it is not even, then we cannot multiply matrices directly.
Right, I think certain assumptions will need to be taken there. Maybe you will have to add some dummy zeros to ensure that this happens. Okay, so you can.
Sir, how is that R equals to AE plus BG?
Why is that not? Oh, my screen is not visible anymore. Yeah, it's visible. Yeah, so it's a little bit of matrix thing, right? So you see A, B, C, D, E, F, G, H, all of these are n by 2 plus n by 2, right? Assume they are all even, like whatever works. The dimensions are all taken care. They're all matrices. How would you write C? Think of C as a whole. Think of C as a whole matrix that is n cross n. You will have all these terms. How will you compute the first term here?
Oh, okay, so got it. Sir. Got it. Sir.
So once we get these calculations, can you write the complexity? Recurrence? What will be the recurrence?
8 times Tn minus Tn by 2.
So 8 times T of n by 2 plus, you have to do some additions, right? Additions. What is the time complexity you will take in additions?
N square.
Because you are doing n square by 4 terms and you are doing multiple times, this is all order n square. What is that? If you solve this, what do you get?
Order of n cube.
N log 8 to the base 2. That is order n cube, and that's solid because this is less than that. Right? N square is less than n cube. So we find that epsilon. Order
But
n
is
cube
that
means,
O of,
sorry,
sir, O of n square in the equation of Tn?
yes.
Yes, sir.
You asking how we get that?
Yes, sir.
Right. So you see, you have to do this multiplication, but in combined phase, you have to do these additions, right? So how many terms you have to add? How many terms R has? It's an n by 2 cross n by 2 matrix. So how many terms it has? N square by 4. So you have to add the n square by 4 terms, right? And you do it in all the terms. You have to add these terms. So that is order n square.
Yes.
Okay. So solving you get order n cube. So it's the same situation, right? Like in polynomial, we did all this divide and conquer. We again ended up with order n cube. Now somebody called Strassen found out a way in which you can replace these 8 multiplication. You can do a trick. You can change them by 7 multiplication. You have 8 here. You can get 7 multiplications, right? That trick is not at all obvious. I'll possibly put it on the chat after the class. What are the 7 things he found? Okay, if I write it here, it doesn't help. So they are non-obvious things, but that actually did the work. So he found 7 multiplications by which you can express this, and that was all. So he got it in 70 n by 2. But yeah, this is not something we will expect you to do. So that's fine. Polynomial was much more obvious, but this one was not. Okay, this one I was showing you that similar idea has been extended for other things like matrix multiplication, although in a bit more non-intuitive way, but yeah, it is there. Okay. Now the problem that I want to discuss in detail is something like a slightly different problem. It's a geometric problem. So slightly a problem that involves geometry, right? Even in the tutorial today that we will have, we will discuss a divide and conquer problem that involves some geometry. Okay. So actually in geometry, you will see that divide and conquer also plays a lot of role doing some problems. Let me define a problem. So the problem is actually quite simple, but still you will see some interesting aspects from divide and conquer. So the problem is, so you are given n points in a plane, and we will take a 2D plane. A 2D plane, you are given n points. And your task is find the pair that is closest among all. Okay? So something like you have a 2D plane. You cannot even put an x, right? And you have various points that are given to you. Right? And there are n points. So each point will have an x and y coordinate. So suppose point Pi will be xi, yi. And what do I mean by saying find the pair that is closest? So we need to define something called distance. What's the distance between 2 points? The distance between point P1, P2, or Pi, Pj will be Euclidean distance, xi minus xj square plus yi minus yj square. You may take a square root as per definition, but even if you don't, it doesn't change the order. So it's a square root of this. Okay. So the Euclidean distance. Now you can define this distance between every pair of points. Right? So now task is to find out the pair of points that is closest among all. Is the question clear?
Yes, sir.
Okay.
Yes, sir.
Okay, now the question is clear. Good. Now how will you go about solving this? At least you should think of the brute force, the simplest naive method. What is the naive method?
The simplest
Choose
method
any
would
2
be
points, find the
choose
distance.
any 2 points and by NC2 and then calculate the.
Oh, tell me again.
So we'll like select 2 points like MC2 and find the distance and like store the distances and like, calculate the minimum as we proceed. So it will be
For
n square.
calculating minimum, you don't even have to store.
Yes, yeah.
You don't even have to store. If you have to sort, you have to store. But if you're just finding minimum, you don't even have to store. So what
Yeah,
you're saying? So choose all pairs. So they are NC2, right? So for each, find distance Pi, Pj, and keep on finding the minimum and find minimum among this. Makes sense? So how much time you will take? How much time one distance will take? That will take some constant time. You are taking 2 points, doing some operation, some like constant number of operations. So that takes constant time. Now you are doing it for NC2 pairs. So there are order n square pairs. So this will take me order n square.
Sir, we can make pairs x comma I and y comma I. Then we'll sort both of them in increasing order, and then for consecutive x's we will check the distances. So in O of n log n, I think it will be solved.
Okay, okay. But how are you using divide and conquer or no?
No, sir, I don't think it's divide and conquer.
Okay, so then after the class, you try out your algorithm and tell us what is the
Okay.
complexity you get. Okay. Yeah,
Yes.
or maybe once we go ahead with this, if you have time, we can take up the solution that we were showing. So good, but yeah, good that you are thinking. So you have this problem where a naive solution will take you order n square. Now question is, we have to do better. And how we will do better? Divide and conquer. We have to do divide and conquer. That is the topic of the class. If it is in the exam, you have to think. Yeah. But at least now you don't have to think. So you are doing divide and conquer. Okay. So now, how will I do divide and conquer? Let's hear. What thought comes to your mind? What can we do? These are the points.
Dividing the plane.
Dividing the plane, good. Dividing the plane into how many parts? 2, 4.
4.
2? Okay, I hear 2. So, let me again put the plane. So you are saying we divide the plane into 2 parts. Let's say we divide like this. So we have a line that divides the plane such that each left hand side, say this is Q and this is R. Q has roughly n by 2 points and R has roughly n by 2 points. So Q and R have n by 2 points each. So to divide the plane, what do you need to do? What do you need to do to divide the plane? How will you divide the plane?
Sort with respect to either x
Yes.
or.
You need the points sorted as per their x coordinates. So for doing that, P was the original points. So let's say Px is list of points sorted as per x coordinates. Right, but here also in this list, each point contains both the coordinates x and y. So it has both the coordinates, but they are sorted as per their x coordinates. Once I sort them as per the x coordinates, I can very easily divide them into 2 parts. I can divide by using the middle and say, okay, I have Q and R, left and right. Or I can even write L and R. L and R, left and right. Okay, good. So we did the divide. This is the divide part. Now what is the conquer part? So divide into 2 equal parts, each containing n by 2 points. Right? So that means a vertical line will be there in a divide. Now what is the conquer part? This is the divide. What is the conquer? What is conquer? Simplest thing?
Comparison.
Recursively do that. Recursively do that. So conquer is fine. Recursively do that. But what is combine?
So minimum of each part and minimum of all the parts.
Right. So conquer is fine. Let's talk about combine. So combine will take solution for each of the subproblems and gives me the solution for the final problem. So let's say you find from the left hand side the minimum distance. What is the output you will get? The minimum distance between all the possible pair of points in the left hand side. So from left hand side, let's say delta 1 is the minimum distance. Right? That's what you will get, some delta 1. And R, let's say delta 2 is the minimum distance. Do you agree? This is what you will get?
Sir, the minimum distance can be between the points.
Yes, sir.
Across
So rightmost point of left part and leftmost point of right part.
No, that's okay. This is what you will get from the two sub-problems, delta 1, delta 2. Now you have to combine them to give me the final solution. So can I just say delta, the final solution, delta is minimum of delta 1, delta 2?
No, sir.
No, sir. Sir, one more distance will be there.
No,
Why can't
sir.
I say that? Why can't I say that?
So there
So
will
what
be
is
some points which near the partition.
So what you are saying, maybe there was a delta 1 here, that is a minimum in the left hand side, and maybe there is some delta 2 here, that is minimum. But what about a point that is very close to boundary, as close as possible here, another point that is very close to boundary, and their distance can be less than minimum of delta 1, delta 2. Right?
Yes.
This can happen always.
Yes, sir. Yes.
Yes, sir.
So no, this will not work. So combine is not as easy that I was thinking. Okay, so if that will not work, so what will I have to do then?
Sir, why will it not work?
Right, see, just think about it. Let's say the left hand side gave you delta 1, right hand side gave you delta 2. And you take the minimum of this. But it can always happen that there is a point at the boundary of left to the rightmost side. Like
Sir,
this
so
point.
we'll add that also in the minimum now.
No, so that I'll come to. But this is not covered in minimum of delta 1, delta 2, right? This distance has never been measured. In left hand side, you only measure distance between n by 2 points, all pairs, right? Some way. In R, n by 2 pairs, only there. But these 2 points have never been compared in the recursive solutions. So the minimum delta 1, delta 2 can be larger than this distance. Do you agree with this?
Yes, sir, but we can always calculate this distance in O of 1
Ah,
because
that we can always do.
are sorted.
That we can always do. But I'm saying minimum of delta 1, delta 2 is not the answer.
No, sir.
Right. Now the question is how, then what do we need to do? Then what do we need to do?
Sir,
If we
we
divide
can
it
do other
into three
partition also.
first part, then we can do the distance in first part and inside second part and inside third part. But then we can also add the distances in first
Oh,
and second.
sorry. So what will you do? First
So
part,
we can,
second part, left, right. What is third part? What is the third part?
so we divide in three equal parts, like n by 3 points each.
No,
And
that will not solve. That will not solve. Why do you think dividing?
Sir, and we can, sir, we can add one more step in this part after
What is
dividing in two parts.
what is that?
Sir, if we find the minimum of delta 1, delta 2, then we can divide a plane which is distance from the partition will be delta 1.
Okay, good.
Delta 1.
What he's saying, fine. Okay.
Delta
Still,
by
let's find delta as minimum of delta 1, delta 2. Right? That I can compute. And now, any pair will create a problem if the distance is less than delta. And one of the point is to the left of the plane, another point is to the right of the plane, right? So now need to see
Yes, sir.
for any point, any pair, Pi, Pj, such that Pi is in the left hand side, Pj is in the right hand side, and distance between Pi, Pj is less than delta. They are the pairs that will create problems. Okay. Now, how do I find all such pairs? So what
From
he's
the
saying,
line, we will see the points only that lie between minus
delta.
delta.
Very good. So what you are saying, okay, that is easy. I can only see the points that are within delta of to the left, within delta of the right. So I can simply have a strip. So that is delta here and delta here. So only points that come within this strip will be eligible, right? No
Sir,
other point
why,
can. Huh?
sir, why not delta by 2 and delta by 2?
Why not delta by 2, delta by 2? Because you see, think of a point that is at 2 delta by 3 here and one point that is delta by 6 here, right? This is eligible.
Yes, sir.
Right? That is why I want to make my life, I mean, I want to make it perfect. Yes, I am not missing any point. That is important. Okay. So if I do a delta by 2, this may miss points. So now I'm sure it will not miss a point. Anybody has a problem with that? It will not miss a point. Right? I cannot miss a point because the distance has to be less than delta, and I'm taking all delta here, delta there. Cannot miss a point. Good. Now my question is, how many points can be here?
Sir, but the entire set can also lie within this delta, right?
Yeah. So so you gave a information that can, say, or we can lose all our hope. Oh, what? Although we are just taking a small strip delta on both sides, like how do we ensure, like there can always be a situation where all the n by 2 points are lying in this strip. So then what will you do? So
But
suppose,
sir, why are we checking for all pairs? So we can check only for the rightmost point of left part and leftmost point of right part, or won't that work?
what do you mean? Think about it. What do you mean the rightmost
Oh,
point?
okay. No, sir.
Okay,
Okay, okay.
the 2D plane, it's not a 1D plane.
Yes, sir. Right.
If it was a 1D plane, you can just sort these and get the conjugative things. It's a 2D plane, right? So now here we are within delta. And our friend gave a very important information that all the n by 2 points may lie. So in the worst case, all n by 2 points of L, all n by 2 points of R may lie in the strip. And what we were hoping that we will just find out terms within the strip and we will compute their all pairs distances, right? That's what we were hoping. But then if I do that, so if I take the all pair distance and find minimum, that is anyway going to be order n square again. So what have I gained? I have gained nothing, like I was in other problems. I have gained nothing, right? No.
Sir,
Oh, yes.
sir, but if all points are in the strip, then the value of delta would be small. Right?
So
No,
so
they
then
can
what?
vary in y coordinate.
Doesn't help, right? Doesn't help you. If it is small, if it is 10 to the minus 5, doesn't help you. There may be another point at 10 to the minus 6 distance.
Yes. Sir, can we draw a perpendicular line and then calculate the distances? Like the same process we do here for this line. For the line parallel to x-axis and for the line parallel to y-axis.
Okay, so good. So you have given an extra information. You see, we have only used the x coordinate till now. We have not effectively used the y coordinate, right? That's what you are saying. Right? We can somehow
So
use.
like we did. Yes, sir. We first divided the plane about this line parallel to y-axis and then about x-axis. Yes, sir. And do the same process, sir. And whatever the both their minimas are there, the answer would be there. Like for the x-axis line, delta 1 would be there, and for the y-axis line, delta 2 would be there.
Right, very good. But then what will be your divide and conquer thing, recurrence formula? Have you thought about it? No, what you're saying is good, but what will your
No,
recurrence
sir,
formula?
I have not thought about that.
4 times m by
You
2.
become Tn as 4 Tn by 2, right? Plus something, maybe order n, and you will get to order n square again. Yeah.
Yes, sir.
Yeah, good try.
Sir, if we divide it first vertically and then horizontally, still there can be points that don't lie together in any order.
Maybe, I'm just saying, maybe, but suppose it doesn't happen, then also you have this 40n by 2, right? So no, that will not be a good solution. But you give very good information that we have to use y coordinate, right? And we should try to use it. Okay. So now, what we will do, we will try to use the y coordinate. Okay, that is the hint that he has given. Hint is try using y coordinates.
And we should consider only delta distance by coordinates from the center.
Good. So yeah, good. So now how do we use y coordinates? Okay. So first of all, I need to have the points sorted as per y coordinate. Then I can use them effectively. So till now I was creating this list px, that is list of points sorted as per x coordinate. Let me also create a list py, that is points sorted as per y coordinates. Right? And each point contains both x and y value under, but they are sorted as per their y coordinates. So I have the list sorted as per y coordinates. Now once I have this list, in this strip I only concentrate on the y coordinate. Okay, on this py list. Now concentrate on the py list. Okay. Now concentrate on py list. That means all points in the strip H, and there we have their ordering, sorted order. Now let's take the first point in the list. There will be a first point. Agree? In the
Sir,
strip
Yes,
that has
sir.
the lowest y coordinate. Yeah, tell me.
sir, PY is the set of all points or only those points which are inside the strip?
See, you will have initially py. So you will sort all the points as per the y coordinates. Then when you are selecting the strip, you can make a subset. You can make a subset. I'm calling them, let's say, py prime, that will contain all the points that are in the strip. You can make a subset. Okay.
Okay, sir.
So they have all the points in the strip, but they are sorted as per y coordinate. Now there will be a first point somewhere, either in the left or right plane. Let's say this is the first point. This is my py1. Okay, or I'll just write it as a point, single point. Now, if I can show that I need to compare this point with only a constant number of points rather than all the n points, I will be in a better position. So now the idea is, can I show that I need to compare this, or I need to compute its distance only with a constant number of points? Okay. So for that, what I do, I create some boxes. So this delta is, right? So let me create some boxes. I'm just putting it somewhere so that I can create the box easily. So let's say this point is here. Now, start a box. So there is this delta by 2, delta by 2. And go delta by 2 down this point. So let's say from here. And now keep on computing these boxes.
Sir,
You don't have to do in the
repeat this part
program. You
again?
don't have to do in the program. I'm just doing it here. Okay. So each box is delta 2 cross delta. Yes, you were saying something.
Yes, sir. I was just asking what was the construction. It's clear now, sir.
Okay. So this is
Sir, it is clear
overall
now.
2 delta. I have divided into 4 parts. delta by 2 by 2 each, horizontally, vertically. So each box is delta 2 cross delta 2. And my point, the first point will lie in one of the boxes. That's how I have constructed. It will lie in one of the boxes. Now, okay. Now what can I say? What can I say?
Sir, each box can have at most 1 point.
Very good. One of the facts is that each box can have at most 1 point. Anybody has a problem with this? Very important.
So can you repeat why?
Why,
Yeah.
sir? We can have more than 2.
So that's what we are arguing. It cannot have more than 1. You see? Think about it. In a box, what is the maximum distance you can get? You know that delta 2 cross delta 2 square. What is the maximum distance you can have in a box?
Delta by root 2.
Okay? So delta by 2 into square root 2, diagonally opposite. Right? So that is still delta by square root of 2. That is less than delta. But we have already seen that delta is the minimum of distance between all pairs on the left hand side, minimum of all pairs on the right hand side, and we are never crossing in a box. A box either comes completely to the left hand side or completely to the right hand side. Is that clear?
Okay, sir. So you are doing it after finding this delta.
Right, of course. Of course, we have delta. That's how we are constructing this. We have the delta. Delta is the very important thing. Using delta, we are doing everything else. So that means this is less than delta.
Hello, sir.
Yes.
Sir, delta can be different, like for one half and another half.
Delta can be
Different.
different.
Yes, because in this half, delta 1 is the minimum.
No, but we are taking delta as a minimum of delta 1, delta 2.
Okay, then.
We have already defined that. Delta is minimum of delta 1, delta 2. Okay. So now do you agree with the fact each box can have at most 1 point?
So,
Yes.
how will we
Yes,
take the
sir.
boundary conditions
Yes,
into
sir.
account? Like if a point lies on the boundary of a box, like in which one do we consider it? Because like
Doesn't
we
matter. Consider anywhere. Make a arbitration that okay, if it is lying at the boundary, consider it into the left hand side box, or the box that it can come. If it is lying at this boundary, take it in this box. Doesn't matter.
okay, sir.
Doesn't matter.
But
Yes.
sir, in vertical boxes strip, sir.
Yeah, tell me.
Sir, in vertical boxes strip, there will only 1 point in one box, then other box is empty. So there is 1 point in other box.
No, I'm saying each box can have at most 1 point, not more than that.
Oh, so yes, sir. Got it, sir.
Right? Okay. Now, like boundary condition is not so problematic here because we have taken a much stricter version. This is less than delta by square root. So even if you see boundary, it's not a problem. Okay. So now let's say this simple case, it is not at the boundary, it is in one of the box. Then how many boxes I have to compare this with? So, awesome. So I have to compare it with at most up to that many. I don't have to go to this block at all because this is delta by 2 is already larger than delta by delta, right? So I need to only compare with this these things.
But sir, why will we set in the y direction? Because it is already on one side of the partition. So there will be no point which is less than that.
See, that's all right. I just want to prove that I have to compare with the constant number of points. We can reduce that constant. That we can do. Sure, I agree with you. We don't have to even compare with these things. We have to, but for that we have to do some more work. We have to find okay which side it is and all that. But I'm saying just think very simply. In the worst case, I have to compare with these. 8 points. And actually, right. So I'm sorry, I have to compare also with this. So I have to compare with 12 in these 12 squares. Did I miss something? So 4.
Sir, why
4.
12 and not 8?
Okay, we can reduce. I'm saying yeah. 12 is will 12 work. That's what I'm thinking. 4, 4, 4, 12. I don't have to go beyond this.
Below the line also, right?
No, but I'm going from the lowest point. So that point I have to compare with the next point. So they will come up. They'll come up. Again, next point I'll
Sir, we
compare
need
with.
not compare it with the same strip, right?
Right, so we can do 11. Okay. Sure. But yeah, if it is at the boundary, then there may be a case I have to compare with both, suppose. So 12 is a limit. You can reduce that further, I agree. You can actually reduce it to 6. Okay, you can reduce that to 6. But let's say 12. We can even work with 12. 12 is a constant. Okay. But I just want you to see whether 12 will work or I am missing something.
Sir, like we start
What
from.
are you writing 4 here?
Sorry?
Sir, what is 4?
In this particular vertical, in this particular horizontal thing, there are 4 squares.
Yes, sir.
In this 4, in this 4, 12. I don't have to go beyond this.
But sir, we can see only the other side of the partition. So it can be 2, 2, 2.
Oh, that's all right. That's why I was saying you can do it with 6. Right. So you can do it with 2, 2, 2. That you were saying good. You can do with 6. Okay, let's say 6. Okay, yeah.
So why aren't we checking the point, like the region below the point?
Because we are comparing from the lowest point. Lowest point is the lowest point. So then I have to compare with the next 6 points. Found out only 6 points on the other side, right? Then once I've compared, I will find the minimum. Then the next point I don't have to compare with the below points again because I'm going from bottom up, right? So I have to compare only with the above points.
Okay.
Comparison with the below point has already been taken place earlier.
Yes, sir.
Sir, in that case, the topmost 4 points should not be taken because if we are starting from bottom, then we just need to check the immediate upper strip and the strip in which the point is present.
No, they are delta 2 by cross delta 2 strips. So think about a point being here and a point being here. The distance is less than delta. The distance is less than delta. So you have to see this strip, you have to see above and the above. You have to see these 3 strips. That I can see. Yeah, you have to see these 3 strips. Do you agree?
Sir, if the point is on the left strip, then it will be still, we can reduce.
अरे ठीक है मतलब in the worst case you don't have to go beyond 6. Is that okay? I was even fine with 16, but let's say 6.
Yes, sir.
Okay. Yeah.
Yes.
So that is the thing. So once we have this construction, that means each point has to be compared only with a constant number of points in the worst case. And here we have found 6. So at most 6, not more than that. Right? So once I have this, then what is my recurrence? Tn, I divide into 2 things of n by 2 each, plus extra work I am doing is this comparison. This comparison I am doing in this history. How much time it will take? in the worst case, there are all endpoints in the strip, right? And I have to compare each point with the next 6 points in the worst case. So this will still give overflow. And what is this? What will this give you? You have solved this multiple
Sir,
times.
but sorting might take n log n, right?
Yes, sir.
I'll come back to that. I'll come back to that. So how much time this will take? Order and log n. You agree with that? Very
Sir,
good.
here
Now,
is it order of n or 6? Sir, should it be order of n or 6 of Tn by 2?
No, why 6 of Tn? I'm not doing Tn in each. I'm just comparing a point with another point, a single comparison. T1, sorry, constant time thing, n times at most.
For each point, we are doing 6 comparisons.
Right. But if I'm comparing 2 points, that's a constant time thing. For comparing 2 points, I don't have to go to my algorithm. For comparing 2 sets, I have to go to my algorithm.
Okay.
So this is order n. So if you solve that, yes.
Sir, I am not able to get it, sir.
What are you not able to get? Tell me exactly what you are not able to get.
How it is coming out to 2 into tq power tn by 2, sir? Tn equal to 2 into tn by 2 plus big of n.
Like you do in merge sort, you have a set of n points, you as per x coordinates, and you divide it into 2 parts. Each has n by 2 points. Each L and R have n by 2 points, and you recursively solve it. So this is 2Tn by 2. Plus, you do extra work in this strip for comparing each point with the next 6 points at the most. So this is Tn as 2Tn by 2 plus order n.
Okay, sir.
Okay?
Okay.
Exactly.
Good.
And this gives you order n log n. But now there is an issue, as some of you pointed out. Well, this is all good in theory, but when I have to actually program it, and when I have to code it, I'm talking about sorting, right? I'm talking about sorting. Sorting, which sorting is problematic, as per X or Y? Which sorting is problematic?
Why?
Y. Because X I can sort once, and I keep on taking the indices. I don't have to sort again.
Sir, do we need to sort? Yes.
I need to sort. In my algorithm, I'm using the sorting. My point should be sorted both as per X and as per Y. Right?
Yes.
So I have two lists, Px, Py. Px is the set of points sorted as per X. Py set of points, same set of points sorted as per Y. I need to maintain these two lists. And that I can do beforehand. That n log n will anyway be taken care here, right? If I use merge sort for this, all n log n is taken care. So if I do sorting in the beginning, it's not a problem. Order n log n plus some other order n log n terms for sorting, for creating the two lists. Not an issue. What I have to prevent myself from is sorting during the recursion calls. Do you agree? If I don't have to sort during recursion calls, I don't have an issue. Now what you need to convince yourself, I can help with that. You don't have to sort during the recursion calls. So you do that, I mean, one time effort. And during recursion, you don't have to sort. You can make your calls in such a way that you pass both the sorted list. In the next call, you actually find the points and you pass them. You don't have to sort again and again. So you sort it once and then keep on passing it. It's actually a very good exercise if you try to implement it, right? So if you will sort it again and again, this will come out to be order n log n square. Okay, you get this extra log n term. Okay, but you don't have to sort that again and again. So this is something, why don't you try? Try this. And convince that you don't have to sort again and again this py. Do it once and that will work for you. Okay? And that is
Sir,
sufficient. Yes.
Sir, in the Tn equation, sir, how it is coming order n log n?
Have you never seen this equation earlier?
Sir, this comes from the merge sort, but if we apply the master theorem, it gives order
No,
n,
master
sir.
theorem you cannot apply here. Yesterday we tried, right? If you try master theorem, this will give you order n log 2 to the base 2, right? Order n.
Yes.
But what was the constraint? This fn.
Epsilon is 0.
Yeah, this order n should have been order n minus epsilon. N 1 minus epsilon. But this epsilon is 0. So you don't find that epsilon greater than 0 here. So you cannot apply master theorem.
Okay, sir. Okay, sir. Thank you.
Okay, sir. Thank you.
That's why I said merge sort will work. Okay, so yeah, this is what I had to tell in divide and conquer. There's a lot for you to think about and actually think about and try and code this. Okay, and these are standard problems. You will find their codes on the internet. I can give you code right now. You can find on the internet, right? But it will be helpful if you do it on your own. That way you can practice what is divide and conquer, and you will come up with problems and you will solve. Okay, and you can always see the code available on the internet.
Hello, sir.
Yes.
So we are taking first input and then we are sorting. Yes. So can we do it while taking input? We can sort it without sorting once again. I mean, there are STLs in C++, I know, but how to do it without using STLs, taking input and also sorting, taking sorted input. So did you get it? Hello, sir.
See, you have to keep on passing those. Okay, so you are saying you will need to use STLs for this.
Yes. Yes,
Okay,
like I said.
Sure. So why don't you try? Maybe you have to, but I think you don't have to. Okay, so
Sir, we can sort while taking input using linked list. That
No,
will not
that
be
is
efficient.
order of n. So
N square. Yes.
Yeah.
will not be. Linked list will not be. Okay, why don't you think over it? Okay, if you think it cannot be done by STL, we will discuss again. Right?
So even if we use STL and sort while taking input, it will eventually come out to be the same complexity.
No.
No, it is O of 1.
It will be your order and log. It will come out to be order.
No, sir. Why
This is
taking
called.
For STL, taking input is O of 1. Like it means, and then we will.
Sure. I think you take your time, think over it, and do it. What I will do, we will create a channel where you can ask your theory doubts. So give it some time. If you still have doubts, put it there. I'll create a separate channel. You can ask doubts for Professor Mage, to me, anything on the theory topics, and we will answer you there. Okay, but first try and see what you can do. Okay, because next 55 minutes we should use for your tutorial. That is very important for your next lab. Okay, I don't want to take more time because you should use the tutorial for the lab. Okay. Is there any pressing question other than how you will implement it? Implementation, yes, you have to think. I have already told you, you have to think. It's not very straightforward, but it will come out to be order and login. But I guess we did it very slowly. You understood why this is and login. But it's just about you have to make it work in program. Okay, so I think with that I will end. We will start tutorial. I'll ask the TA if he can join in the same link. So do you want to join the same link? Okay, next week we will have to lab on divide and conquer. And today I'll give you some problems. Now, do you want problems with solutions or only problems? I can give you either way.
So with solutions.
With solutions.
With solutions.
You don't want to take a risk. Okay, fine. I'll give you problems with solutions. Fine. Directly. Sure. I hope some of you try to hide the solution and solve it. Okay. Okay, Punija is already here. Yes, Punija, I can make you a presenter. Okay, then I will stop sharing my screen. Okay, so Punija, can you try sharing your screen?
Yes, sir.
Yes, I can see your screen.
Yeah, is it visible, right?
Yes, yes. Okay, so Punija, it's over to you.
Okay.
You can,
So everyone can hear me, right?
Yes, sir.
Okay. Please stop me anytime if you feel any doubt or like if you have any questions. Anyway, we will have a bit like an interactive session so that we can actually solve this question. So basically today our target is to, so this was based on the feedback from last year. So we planned that we will solve the past year lab assignment. I'm not sure how many you have like seen the assignment or like tried to solve it, but let us first go through the problem statement, and you can read it. I will also like read that problem statement, and then we can see how to solve it. Okay, so the problem statement is basically we are a training institution which is like creating devices to help people with defective eyesight. Take the marker. Yeah. So then you have been assigned to a group which deals with binary eyesight defect, and where a person can only see two colors. So this is, I think you know about like color blindness. So this is a bit like more defective than that. So there are like two colors, black and white. That means that if two objects have a greater contrast than a particular threshold, then they can be perceived as different. So did you understand this point? Like what they are trying to say? Any one of you can answer me.
Like if the difference between the contrast is greater than a particular value, then they can differentiate it.
Yeah. So we will try to see an example of how it is done, but let us continue with the problem statement. So now they are saying they are at the initial phase of the project and they want to understand the stress faced by these people in recognizing objects and the loss of depth perception. So you have been tasked to get the perspective of these users on a set of rectangular objects. So, and one of the constraint is that you are looking right at the objects and you can only see the top of this object. So this is actually due to by this thing you can like there is no information about the depth of for this object. So to you it appears like they are 2D objects. And finally, so here the main thing is there. So the objects are of various colors and the background is white. So the defective eye will not be able to differentiate between each of the objects, but there is enough contrast to differentiate between the objects in the background. So this is the problem statement, and the task for you is to convert to devise an algorithm basically to convert a normal vision to that of a defective vision. So let us see an example first. So this is one of the examples. So these are the objects. This blue like rectangles are the objects, and this is the defective vision. So ideally it should be like the total. This should be black, and the this should be white, and this should be the perspective of that user who has a defective vision. So how should we? Yeah. Do you have any questions?
Sir, how is that lowermost horizontal line is being perceived as a thick line?
Yeah, so this is a constant for from the problem. So any line that is So the line that is connecting two, let's say, separate blocks is marked with a outline, or let's say the defective vision is also there. So that is one constraint of the problem that is present. So if the line is at the lowermost point, like the horizontal, you have to consider it as a part of the defective vision.
Sir, the existing blocks base, like from let us say less than 5 to greater than 10, that is marked as light. Why is that so? Means that will not be perceived as a dark line.
Which one?
Like from 15 to 25, let us say, there is a base. So that won't be perceived as a boundary.
15 to 25, there is.
Means the base also has some, if we are perceiving it as a boundary, then why haven't we drawn that? Means is that some assumption that is made out?
So from 15, so let us see. So let us see the example. So let us start from here. So what will be the initial boundary? This line, right? So for the defective vision, so this will be the initial line. Then you move here, and in about these two blocks, you cannot separate them if you think from a perspective of the defective vision. So you move above, and then again you can differentiate here because the background is white and this is a color piece. So then again you can draw a line here. Similarly, for this again you can differentiate because there is a color piece and this line is there. So everywhere where there is a white and a different color, you can make a boundary.
Okay, sir. Like even at the bottommost points, there is a white boundary and a blue color, or say green color. Then we have not made a boundary there.
Oh, you mean here?
Yes, sir. Yes, sir.
Oh, okay. Okay, so this is so. So you can consider it like that, that this is the lowermost point. So you do not need to, so the lowermost points are anyway connected. We can say that they are part of the boundary, but they are anyway connected. Like it is not required to show them separately.
Sir?
Yeah.
I think, sir, the bottom part is relevant to question or not?
No, it is. So we only have to show, so you can assume that this line is already there, like the connection is already there. You only have to mark the total outline that is above this last line, except the points where they are getting connected again, like this one. So is it clear now? Hello?
Yes, sir. Understood.
Yes, sir.
Okay, then let's check the input. What is the input function here? So like inputs that are provided to you. So a rectangle can be described by this point. So you can consider all the rectangles in this 2D plane. So there is no like space in this line and the rectangle position. And if that is true, then we can only use these 3 points to represent rectangles, and that is also the input. The first point is the left boundary. The second one is the right boundary, and we only need the height, and we can describe this rectangle. So I think it is clear. This is very simple. If you have any doubts, then you can ask. So in this way, all the different rectangles are passed in this input. So one, we will look into this later, but for now, let us think they are more or less sorted. But the final question is that they can be in any order. They are not necessarily in a sorted manner. Just to show this, I have added the inputs in a sorted version so that you can identify which rectangles is which. So then you have to present the output, and in the output also you have to mark some points. So again, the points, the constraint of these points are that they can effectively describe this output line or the output outline that is shown. So for example, so I hope you can follow it, right? So 2,10, you draw one line, then 3,15. So you can first go to 2 to 3 and then go to 10 to 15. So this way every point is defined such that you can describe this outline.
Sir, why is it not 3,10?
3,10. Yeah, so that's what I'm saying. So 3,10 is a redundant point because you can show that. So let's say 2,10 is there, then you don't need 3,10. You can directly, so if you place 2,10, then 3,15, you can first go from 2 to 3 and then go from 10 to 15. So that automatically is included in this point. Because if the basic idea is that you cannot join these 2 points directly, you have to follow a rectangular path or a broken path. So that's why 3,10 is not required.
Okay.
Similarly, like if you check for any other points also, let's say this point also, this can also be represented using these 2 points. So you move from 3 to 7, you move here, and then from 15 to 12, you move downwards to reach this point. So this is the minimal representation of the points that can describe the outline completely.
Sir? Yes. Sir, for the first step, why are we going first horizontally and then vertically? I mean, is it said it like that? I mean, if we go first vertical and then horizontal, then the whole structure will change.
Yeah, but that you have to follow according. So I am saying how you can only specify these 2 points and then describe the outline.
Yeah, I'm saying that if you only specify the points, then I have to also specify the first step also. I mean, in which direction I'm taking the first step.
No, if you took the first step vertical, then it wouldn't be a corner.
Yeah. So if you take the vertical first step, then ideally what will happen? The final outline will be here, right? So it will not remain here. So whenever you are having a corner, then you only specify outline. And another point is that the corner should, like the point should be marked only when it is not redundant. So that's why you are not marking every corner, because those points can be described by the other points that are present. So if you have to go vertical, then this point is not the outline part. So basically, if you have to go the corner,
integer.
So let's say the red box is just as a side, like at here. Then what will be the outline there? So the outline will be the top of this red box, right? Yeah, you are asking something. I did not get it. Hello.
Sir, is the input always integer?
For this question, I guess yes, but yeah, for like you can consider it float as well. The algorithm should not change. So for this question, I think for keeping it simple, it is always considered as integers. But for now, let us not delve into the like syntax and all. Just let us visualize what should be the algorithm, because like if it is float also, you can apply the same algorithm and just as the change of the input dimensions or like the input type. Okay, let's move ahead. So let's think of a very simple approach. So can anyone like tell? Can anyone tell what can be a very simple approach? So you already know this is divide and conquer tutorial. So we will move to that part. But let us first try to understand what can be a very simple approach. So initially, I am telling you the initial step. So initially, what we will do we will mark key points for each block. So the key points will be one point at the left and topmost corner, and one at the right and bottommost corner. So we will do this operation for each block. So for red, it will be one point here and another point somewhere here. For green, it will be some point here and then another point here. And that way we will complete this whole structure. But now can you tell what will be the algorithm, or what is the next step for, let's say, one key point? What can we do to calculate the final outline?
Sir, I think we can check all the key points which are hidden and then eliminate those.
Okay, this eliminate the hidden points.
Yes,
Sir,
sir.
we sort first with respect to x coordinate because we have to start from leftmost side.
Okay, you can sort then.
Then we can
what
move in terms of height.
We can move
In terms of height, means increasing order of height.
So you want to sort it them in increasing order of height.
So decreasing will be better, I think.
Yeah, okay, that can be one step. Then what we will do, let's say we sorted in some order, then what should we do? Though it will be like sorting is not necessary, but let us consider for now that it is
yes.
done. Then what should we do?
So we need to check if the key points are inside or outside another block, so if it's overlapping or not. So what we can do is we can like some sort of binary search. We can do x2 plus x1 by 2, check if the middle point is inside or outside, then keep doing it until you reach the edge.
Okay, okay, close. Okay, yeah, that can be one such a good idea. Yes. So let us look at the actual thing. So what is done for each mark point? If buildings with more height overlap with it, change y to the maximum height of the tallest overlapping building. So what you are suggesting, it is basically a more like simpler version for that. So whenever, so let's say consider this point, particularly the one that is covered bordered with white ink. So let us consider this point and try to understand what will be the final position of it. So can anyone tell what will be the final position of it based on this if condition?
The y coordinate will move up to the red roof.
Yeah, okay. Yeah, that is correct. So let us take maybe 5-10 minutes and like draw this outputs and try to come up with this outline, just a step for each of this marked key points. And maybe you can share an image in the common chat after you've done. So just draw this outline and then try to mark first the common points, and then using this if condition, just mark where will be the final points for each of these marked key points. So we will stop for maybe 5 minutes and then we can discuss what is the output.
So is it sufficient if we do this? like we finish this procedure, we just join all those points. That's sufficient for the problem to be solved.
Yeah, we will come to that, but let us first do this step. So there is one more additional step that is required, but let us first do this step that is given here, and then we will move from there. So this is basically the main step, but after that you have to do one more step to get the outline. It is mostly based on whatever we covered in the introduction about overlapping points. But let us first do this step, and then we can discuss. Has anyone completed?
Yes, sir, it's in the chat.
Oh, okay. Sorry. Yeah. Yeah, Anubhav, your answer is correct, but I did not get Tanmay's answer. So how will it be
Sir,
like?
I thought you said, sir, I thought you said only to draw the outlines based on the points we got.
Oh, okay, okay. Oh, okay. So, but again,
Sir,
like these points will not go till here, right?
Okay, sir, I'll revise the diagram.
Yeah, it is not required now. Just I think Anubhav's answer is correct, so you can refer that. And if you have any doubt, let me know later. Okay, any other questions? Otherwise, we will move
Sir,
on.
I think I missed the point.
Red building.
Yeah.
Will it move up?
Yeah, let us look at the solution of this at least. Yeah, so I think you have proceeded like Anubhav, you have proceeded like this. So this point will move up to here. This point is part of this red building. So the highest position it can go up to is the green building. Similarly, this point also has
The overlapping buildings. Red is itself the highest.
Yeah, for that you have to move it to the next highest building. So whatever it is, for if buildings for each mark point that is part of some building, if buildings with more height overlap with it. So here the overlapping building will be green and blue, not red itself. Like red itself is already there, but other than that, what are the buildings that overlap?
So the blue one shall go till top of the red or green?
No, it should stay here. So that's what I said. So the blue one is part of the red block, right? So it should go until the green block because that is the highest building apart from red.
But sir, in the point you said that change y to maximum height of tallest overlapping.
Yeah, so,
So
tallest overlapping. So this is not with the same building. So because so try to understand the logic behind this. So if you move this point to here, then this is anyway redundant. So you do not need this point to describe this point. Need this other point to describe this point. So that's why it is not required to move the blue block to the top of the red building. But yeah, any questions?
yes, sir. How can we know
The tallest
which?
among the overlapping buildings,
Yeah.
not the current one.
Yeah, not the current one. Yes. So the mark point should be part of a building. Apart from that building, whichever building is overlapping with it, change y to the maximum height of that tallest building. Yeah, is it clear now?
Yes, sir.
Okay. So the final step is removing the redundant point. So can you just say what should be the algorithm for that? It is very simple actually. So based on this,
do we actually need to remove them?
Yeah, so you have to represent the minimal boundary that we already discussed in the introduction.
Okay.
So the algorithm is very simple. You can just say it if anyone has.
Sir, if the previous point is
change in y axis.
Yeah. So if there is no change in the y-axis, and in that case you have to keep the leftmost points. So here there is no change in y-axis, and you have to keep this point. Similarly for this. So that will finally give you this output. So you can continue this to this output. So it is simple. Now, what about the time complexity? So, I guess Pawan sir has already covered a lot of this, but let us just think what will be the time complexity for this. Try to think for each block what you have to do, and what will be the worst case for.
So we need to check for each point with which it is overlapping. So I think it should be big of n square overall.
Yeah, correct. So it will be a O(n) square algorithm. So now let us move to devising a more efficient approach. So here we will
How it became O(n) square, I couldn't get it.
Okay. So let us say this block is there. So in the worst case, what will be the number of blocks that you need to check for, let's say, this point or this point? So what will be the worst
When
case for?
nothing is overlapping.
That is the best case.
Oh.
What will be the worst case? That so consider one
N
block
minus
and one mark point. You may have to compare it with all the blocks. If all the blocks are, let's say, overlapping with this block, then you have to check for all the blocks, right?
Yes, sir. Yes, sir.
Yeah. So for each block, you have to check for all the blocks in the worst case. So for n blocks, you have to check for n cross n, so n square.
So, but without checking it in the first place, how do we know if they're overlapping?
No, that is not the point. So the ON square boundary is given based on what would be the worst possible time that will need.
So, but even in the best, I mean, looking at whatever pseudocode is giving here, even in the best possible case, even when it's a point is not overlapping with anything else, it still has to check with everyone to ensure that it's
exactly.
not overlapping, right?
Exactly.
Yes. So regardless of best case or worst case, it's always over.
Yeah.
Yes.
Yeah, so it is clear, right, that it is ON square. So this is very simple, like algorithm wise. So let us move to devising a more efficient approach. So can we think of a divide and conquer approach for this? What can we let us look at this example only. So what can be the divide step?
So we can divide like a line parallel to y-axis where no building has its boundaries.
No,
Based on x coordinate and y coordinate.
So you will be given some points which are not sorted, which are given, but they are not sorted in any manner. So what will be the divide strategy for that? You
Based
can
on
just
x coordinate,
divide
y coordinate.
Yeah, you can just divide at the middle element. So let's say this is the example. So this is the given points. So you can just divide here. So after this division, let us see what happens. So yeah, so this is so you can divide at so you can divide it here. So then you get these points, right? So these are the blocks to the right, and these are the blocks to the left. I think I divide the blocks at this point. So these are 2 blocks left side, and these are the 3 blocks right side.
Sir, we are dividing randomly, or in some sorted manner we are taking the middle element?
No, the sorted. So it is not sorted exactly.
So we are
it
just
can,
taking the central, means
central element
irrespective of input.
Yeah.
Okay.
Central element. This is similar to what we do for merge sort, right? Or let's say some other divide and conquer algorithm. So you have the blocks to the left and blocks to the right. You just divide it to blocks left and blocks right. Now you can now what will be the step? You can draw the outline for this one, and then the outline for this one, and then you can then merge it. So this will be similar to get a defective vision for this left block, then right block, and then simply merge. So is this part clear?
So initially we saw this idea work out for rectangles, but in this case they're not like when you divide them into 2 sets, the output of each set is not exactly a rectangle. So I'm just thinking if that property still holds, that if you push the points up.
Yeah, we will. So yeah, that will not hold in this case, right? So that was for the simple algorithm. So that thing will change. But I am saying, just visualize that when you divide it into blocks left and blocks right, these 2 problems are actually becoming the sub problems. And now you
Okay,
can solve them individually and then merge the output. So that will give you the final output. We do not know what the merge algorithm is still right now.
Okay, cool.
So we will go to that later. But till this part, it is clear, right? So this is the basic structure of this code that will require. Only thing we don't know is the merge algorithm.
So the top right image is before merge.
Yes, the top left right image is before merge because so I have showed it using different colors, and after merge is this image. Yeah, so now the merge algorithm. So this is the most crucial part of this tutorial. So how to merge these two outputs. So again, like the one that we did for the initial algorithm, I will start with the first statement, first part. So similar to merge algorithm, like merge sort maybe, we start with the leftmost points for both this defective vision outputs. So this is again like as I said earlier, this is from one let's say the left side, and this is for let's say the right side, or vice versa. Now the main task for us is to merge this. So what do you think will be the next step?
So do we remove the redundant points just like the previous step we did?
That will be at the end, but not now. So for now, keep the redundant points, but just think what will be the next step.
So we go x by we increase the values of x slowly, so that from one value of x to another value of x we start drawing. Regardless, we merge the two sets of points. We consider them to be one set. Then we go start traversing it from like in an ordered fashion.
Okay, let me
Sir?
Reduce the complexity a bit. So let's say you have these 2 points, the leftmost points here. Now, which point should you select?
The leftmost point.
The leftmost point. So that is the next step. Now, so we'll come to this step later. So you have.
So I think we can use 2 pointers technique. Like we take 1 pointer for the one,
this is,
one, and
this is simply the 2 point case. So we choose the one with less x value. So this is this point. Now let us leave the third case for a while. We will look into this once we reach we have this problem. But for now, it is not not there in this. So after this, let us just see. So we have selected this point. Now we move to the next point, next key point. So the next key point will be here, right? So so can you tell me where will be the next key point for this the red line?
It will be raised to the blue line.
No, not that. So I am saying, let's say this is the key outline or the outline of the defective vision. So this is the first point of this outline, right? Now I am asking, where will be the next point in the outline for this red part?
Go right and
Below
point
5. Between 5 and 10. Below.
Yeah, here, right?
Yeah.
Yes, sir.
Yes, sir.
So we proceed. So leave this part for now. We will return to this once we face this situation. So next we proceed to the next point. So that is this point, and we repeat this step. So now we have this points, this one and this one. Again, we need to choose the one with less x value. So we choose this point one with less x value, and then what will be the next step for this? This blue outline. What will be the next outline point?
15. Lower part.
15. Yeah, and below.
So moving it here. So now you have again 2 conditions. Now you choose the one with less x value. So this will be the one with less x value. Now the main step, that is the part that we are leaving for now. So if y value of chosen key point is less than last seen height of other defective vision point. So that means that if the last defective position was this, and the y value for this current point is less. So we have to update the key points y to last seen height of the other defective vision point. So what will be the final position of this point? So this is exactly similar to what we did for the simple approach. So tell me what will be the position of this point based on this condition?
The same
Sorry.
as
One by one, it will be better. One of you can speak maybe.
Sir, it will move vertically up till leftmost blue point. Means left height of this point will become equal to leftmost blue point.
Sir,
And
yeah.
Sir, we will choose the like blue one's first key point. Like we can like we have to print that point, no? Like the first point of the blue one.
No, first point of the blue one means which one? So
that tab like 7,10 one.
7, so this one will move to where? So 7,10 means here, right?
No, sir. The first key point of blue one. So have we like considered the first key point of blue one?
No. So the algorithm is so you have to consider the last seen height of the previous like defective vision point. So this will be this one, right? So this is the leftmost point, then this point. So this has height greater than this point. So if this is the condition, then we have to update the key points of this point and move it to the last seen height. So the last seen height is this 10 or something like around 10. So we move this point to this point, somewhere around this. So this will be the final step.
Yes, I got it.
And again, we have to choose proceed to the next key point. So here was the last point. So the next key point will be here. I think you have got it by now. And we have to repeat the steps. So now let us try to make the final figure. So this will be similar activity, similar to the last one we did for simple approach.
Sir, I have a doubt here. Sir,
Yeah.
can you just move one slide before?
Yeah.
Sir, one more. When you were choosing, yes, sir. Sir, here, if suppose the blue box, the blue outcome, if suppose it has ended earlier, then this we should not increase the height of current point with as much as the last seen height.
I did not get your question. Maybe if it is possible, can you write in chat? I can check it.
Sir, I wanted to
Your
say
voice is
that.
breaking up.
1 minute, sir.
So Vishal, I guess you have had a question and missed that. So we are dividing. So for this red and blue line is just for showing how the merging takes place. So ideally, you should get this when you are doing the divide step. So maybe there were some blocks here, and you had run the divide step for those. And finally, in this step, you have got this outlines, and now you have to merge it.
Okay, sir. Thank you.
So we are not showing the total algorithm here, just the merging step.
Sir, is my voice fine now?
Yeah, your voice is fine now.
Yes, sir. So my doubt was that the current point, which is almost 7,4. So while deciding it, so suppose the blue block, if it is ended before this point, then we should not increase its height, right?
No, then we should not.
So
if the last in height is less, then you should not increase.
okay, sir, then it's already covered, right? Yes.
So the best strategy, so let us complete this tutorial, then I will say the best strategy will be try to draw this outline, think of any possible combinations, try to draw outline, and then see if you by following this algorithm you can cover it or not, like cover this outline or find this outline or not. So I think this algorithm will cover most of them, if like all of them. If not, then just if you have an issue, then just ping in this chat. So keep it for later. Let us just finish the tutorial for now. So try to think of other outlines where you feel this might be like this might not happen or something. So this is the final. So this is the next step. So now what we will do, we can again wait for let's say 5 minutes, and then try to come up with the final figure for this algorithm. So for now, do not remove these redundant points or something. Just draw these key points based on this outline. So keep the redundant points as it is. We will just like say that at the end. But for now, just try to draw the outline. And then similar to last time, you can post it in the chat.
Sir, do you have the link for this question?
Yeah, I have it. I will. So I can share it now, but it is easily searchable also. But it will be better if you first try it and then see the solution. I will share it with when I share it.
Sir, I'm
When
not
I share
seeing
the
the
tutorial slides. Hello.
I don't want to see the result. I want to see some examples for that. Sample output.
Sample output.
Yes, sir.
So by sample output, you mean the final output that is presented?
Yes, sir. Sample inputs and output.
Okay. So I will share the link of this question. So it is taken from Geeks for Geeks, but I will suggest that you please try it once, like write the questions once. Or I can let me try to see if I can get the sample. So please complete this figure, and then we can start after 1 or 2 minutes. Yeah, I have shared some of the test cases that you can use for later writing the code. Okay. Yeah. Yeah, Saurabh, I think you have missed one point, the second last point. Can you check like if it is correct or not? Yeah, Anubhav, your answer is correct. Great. So you can refer Anubhav's answer for the final figure, and I am also showing it. So, yeah, this will be the final output. So then again, we have to do the last step, removing the redundant points. I think you remember from the simple approach. This is similar to that. When you have two points with same y-axis, you have to take the leftmost point. Or two or more points, you have to take the leftmost point. So then we are removing. So we remove this, and finally we get the output. Now let us see one corner case. So what should we do if we have the same x value in the second step? So by second step, I mean where you have to choose the one with less x value. So what should we do here? This is a tricky case, and this our current algorithm cannot solve. So what can be the solution for this, like handling this corner case?
Choose the one with the maximum y coordinate.
Choose the one with
maximum y coordinate.
Yeah, and then do we require
increment both, I guess.
Yeah, exactly. Choose the one with higher y point, and then move both the key points and skip to the third step. Okay, so this is the entire algorithm here. To summarize, what we should do. So this is basically what how you have to think for the lab assignment as well. So when you are getting a question for divide and conquer or any other cases, start from a very simple example. So our simple example was just this, like the simple approach that we're thinking. Or just take, so for this example, you can just take two blocks and then try to see what the outline is. Then we can try to take a more complex example and try to understand what can be the divide step. So if you have an idea about the simple step that we are, like the O(n) square algorithm or something, you can then try to think what should be the divide step. And once you identify the divide step, you should have something similar to merging or conquering that both these two steps into one step. It can be a conquer algorithm, like conquer part, or something like merging, so merge sort, where you have to merge this. So think of the algorithm for this and then handle the corner cases. So I hope it is more or less clear, like how this algorithm is written, or how we are trying to solve this. So your task will be to, yeah, tell.
Sir, could you please repeat the corner case once again?
Yeah. The corner case is where what happens is same x value in second step. So this is the second step where I have to choose the one with the less x value. But we cannot choose here. Hence, one with higher y and advance both key points and skip third step. The third step was
skip
this.
Third step. Okay, sir. So we add the topmost y to our list. Is that the case?
Sorry, I think it is wrong here. So choose what is question screen. No, sorry. I think it was the second step. Sorry, I will. Should we skip second step? So second step is this. Choose the one with less x value. So we do not need to do this step. And then we can directly choose this point and then compare, then do the third step. But one of the key points is that you have to advance both the key points so that we do not, like we should not check this point again, like this yellow point. That is not required. I think it should be skipped second step.
Sir, but let's say we have chosen the point which has a higher y coordinate, and then we apply the same algorithm to that point, like checking if that is higher than the last seen y coordinate, and then
Yeah.
just
Yeah.
okay, thank you.
Yeah, so that case will anyway happen if we have some y value and the other point is higher than that. But only you during this choosing x value, you have to write an extra if condition here. Yeah, sorry,
Sir?
my mistake. Yeah.
Sir, can you please show me the divide part?
So this point can also be removed during removing the redundant points.
This one. This one.
The last one.
The last.
For 2.7 max.
Yeah, but
we can also
for
keep it as a redundant.
the redundant point, we are only handling the horizontal points or the one with the same y value.
Yeah, I'm telling if we add another case, then we can remove it in that step.
No, but you have to again compare this point with others, right? That will be a more redundant. So it will be an extra step here. You can do that. But you have to again consider this point and then compare. So to remove that, so this will reduce one comparison at least.
Yes.
Anyway, so the divide step here. So yeah, this is the divide step. So who was asking? So what is your question exactly here?
No, sir, I actually wanted to see that divide step. Yes, now it is clear now.
I will anyway share the slide with the corrected thing. So now the final thing is that try to write this code. I will anyway share. This is very easy to search, I guess, but I will anyway share the link to this problem and also this PPT somewhere around let's say Sunday, so that you get time to code it and just try to code it once. And if you have any issues or some problems, then just let me know. And I will share the slides and the link to this problem by Sunday.
Sir, is there a website to check our codes, like submit and check our codes?
For this, no, but I guess in GFG practice you can do. I'm not sure.
Okay, sir. Thank you.
I have given the test cases.
But does GFG has?
Yeah, GFG has a practice block, right? So you can practice your codes there.
That we can do it directly there and check all the test cases.
I am so sure about that. Let me check once. Otherwise, I have given the test cases for now. So, like, I think this covers many of the corner cases as well. So you can try using this. I guess if you can solve it using this test cases or this test cases pass, then your algorithm will be more or less correct. Okay, any other question? Just try to code this problem. Maybe you have to, you may face other problem challenges as well, but those should be solvable. The main gist of this problem is given.
So
Sir?
there's like a standard methodology for solving divide and conquer, which is so is it basically first making a subdivision and then looking at the special merging process? Is that it?
Yeah. So overall, there can be 2 or 3 complexities with this. So for this, the divide step was pretty easy. Like you can just check the input and do. So for some cases, you have to design the divide case specially so that the algorithm like divide step is correct. And then the merging step was a bit complex here, but you may find the merging cases to be simple and the divide step to be complex. So there can be different varieties, but overall you have to first think, how can I divide the problem into sub problems, and then you have to conquer those sub problems. So here the sub problem is basically different outlines, and the conquer step is to merge those outlines. If you also check whatever sir has taught, you will see this pattern here. So you have a divide step and then you have a conquer step. So that is the basic idea of solving any. Now with practice, you will be able to identify quickly what is the divide step and then what is the conquer step. But overall, you should think like that. That's the point. Okay then. Thank you all of you.
Thank you, sir.
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 Sir,
Thank you,
please
sir.
stop the
Thank
recording.
you, sir.
Yeah, you can stop the recording.